The rapid rise of artificial intelligence we've seen in recent years has felt very conversational. We've gotten to know the technology largely through prompting, chatting, and generating. But beneath that digital layer, something much larger has been taking shape. Hi, I'm Chris Hyzy, Chief Investment Officer for Merrill and Bank of America Private Bank. We are witnessing the application of AI begin to drive profound advances across the economic landscape. The race is on to build the infrastructure required for AI systems to operate in the real world, not just in software. More than $41 billion was invested in physical AI in 2025 alone. This isn't about better chatbots. It's about intelligence moving into robots, vehicles, factories, logistics, and more. In other words, AI has left the chat. To get a picture of where we are and where things are going, I'm talking to analysts from BofA Global Research who are closely tracking the trends. First up, equity analyst Martin Briggs. So Martin, let's start right at the top. Can you please explain exactly what physical artificial intelligence is?
Sure, thank you, Chris. Delighted to be here with you and the team. So what we mean by talking about physical AI is that AI is moving from screens to the machines. It might be a robot, a car, a drone, essentially bringing that intelligence into the real world.
So everything that we watched early on in life, whether it was cartoons, movies, about what could actually happen is starting to unfold. You talked about the screen to the machine. Can you talk about why the shift now?
Essentially, there's a number of different things converging. What we see now is a combination of things like world models, simulation, and synthetic data that can accelerate the flywheel and bring that into the real world. So starting with those individually, a world model essentially brings together the tools, vision language action, vision language models, and a number of different software capabilities to allow AI robots, cars, drones, etc., to understand the laws of physics, that if they walk into this table, they're either going to get hurt or fall over or broken, and that they can't walk straight through them. So a different set of models to bring that to life. I also mentioned things like simulation, which can test, validate this technology much faster. One of the companies showed that 1 second in simulated environments would have taken 27 minutes to achieve in the real world without this simulation. And of course, that's been slow, expensive, and billions of dollars that these companies have had to raise to do it. So simulation is making things faster. And things like synthetic data, there's a lack of data available for training of these technologies. Now you can start to do that not just with real world data, but also synthetically to bring these products to market faster.
So one area that investors talk about a lot is value and monetization. So what's the value creation and monetization end of physical AI?
The value might start to accrue in the short term in some of the picks and shovels, the hardware needed, the sensors, the actuators, motors, batteries, AI chips that are required to bring this together. In the mid to long term, it's likely to be more the integrators that can bring together, be it an autonomous car, a robot, a drone, etc. But I think in the short term, we're seeing value accrue in some of the development, the sensors and the hardware. The longer term will be some of the integrators of this disruptive technology.
And when you look across the entire arc of physical AI, starting with why is the first mover advantage, no pun intended, or maybe pun intended here, mobility?
The first reason is that we're bringing scale to the market. There's already a 75 billion sensor market in automotive for driver assistance and safety systems, or ADAS systems. So we're seeing quite quickly that accelerate towards autonomous. So Level 2 capabilities now, potentially fully autonomous on robotaxi applications in the not too distant future. And there's already 10 commercial or cities where you can ride in robotaxis today, and over 200 pilots across either robotaxis or commercial trucks and logistics applications. So the scale is starting to come now, and it's bringing that intelligence into the roads, into the vehicles. The other thing is that the centralized compute, so software-defined vehicles or high-powered compute on wheels, is a big shift that's really starting to play out now in the last few years only. Where we used to have 150 or 200 distributed electric control units in vehicles, now we're centralizing that compute and making it far more powerful that you can do much more disruptive applications on top of it, especially around autonomous, which we wouldn't have been capable or viable only a few years ago.
So you talked about scale and the shift. The numbers are absolutely staggering when it comes to the production and almost proliferation, we're not there yet, but of humanoids. You want to dive into that a little bit?
Absolutely, yeah. So humanoids are one of these areas that have been a lot of hype and excitement around, certainly for the last year or two. It's the pure embodiment of AI that we've just discussed throughout this interview, and things are accelerating very fast. So the hardware's getting cheaper. A humanoid costs $90,000 to $100,000, but many of the companies now say they can manufacture them for maybe $20,000 to $30,000 in the not too distant future. And the type of numbers here, we could move from 20,000 humanoids manufactured last year to maybe 1 million by the end of the decade, and even 10 million in 2035. So we're quite quickly seeing an acceleration of the potential volumes here. If we take a step back and think about how they could be used or where is viable in the near term, it's far more in the industrial applications, right? So warehouses, logistics, some of these areas that are being piloted already, and bringing humanoids into assembly lines and low-level assembly tasks where the productivity gains will justify the investment. So it might be still a while, a decade plus, before we're going to have them cobots in our household or even alongside me here in the office. But for some of the industrial applications, the ROI is being proven out and the pilots and the tests.
Okay, we talked about the physical portion, the arc, value shift, monetization, a little bit on opportunities. You want to go a little bit further on the opportunistic side of the equation for investors?
On the one hand, it feels like things are becoming commercially viable in months rather than decades now, right, for some of these applications. So what that means for investors is that we see a number of ways in the hardware and some of the picks and shovels, ways to enter the market for investors on things like sensors, actuators, body, motor, batteries, etc. in the short term. I think the bigger opportunity, of course, and the more disruptive one will be who is going to integrate and be the customer interface for a humanoid robot or a self-driving car or a drone delivery, these type of applications. There's a mixture of private and public companies that we've identified that do this already, but to do that more successfully commercially at scale is a combination of a few things that need to happen to get to bigger scale. Regulation obviously needs to be a bit more amenable in certain locations, and obviously the technology viability needs to be proven out, but ultimately the integrators of this technology will be the largest beneficiaries in the longer term. For now, we've identified a number of areas in the picks and shovels and hardware and companies that are developing the tools you need to develop and deliver physical AI.
Let's shift to something that is also very important. When you start talking particularly about humanoids and robots controlling certain things themselves, which is the risks. Well, what are the top risks that we should all be aware of?
The biggest risks, of course, will be impact on employment and the pace of that. Also, the risk of the technology hallucinating. Not as much of a risk in a digital application on a 2D screen and a chatbot. You either do the calculations yourself and come up with an alternative. If there is any kind of hallucination or in the real world, be that on a road or if a humanoid falls over, there's real safety risks. So the technology needs to be proven out to far higher degree of safety than you would have in a chatbot application, clearly. And the final risk, I think, as we alluded to earlier, is the pace of regulation and standards and safety standards for these services to operate. Every region has a slightly different view on that, and there's nothing really exists that's standardized globally, which might slow the pace of development of commercialization of some of the technologies. So they're the three main ones.
That reminds me of some 30 plus years ago with the build out of the internet itself, Martin. Final question for you, tough one here. One word answer about physical AI and its future. What do you say?
Exciting.
Martin, I want to thank you for joining me today.
Thanks, Chris. Good to be with you.
Let's turn the page now from one aspect of physical AI to another, where AI is moving from software into machines, robots, and mobility. What then comes into view are areas like transportation and semiconductors. To explore these themes, I'm joined by two analysts from BofA Global Research, Ken Hekster, who covers transportation, and Vivek Arya, covering semiconductors. Ken, Vivek, welcome. So let's start with you, Ken. Take us through what you're seeing in the transportation sector right now, simply from, is it being deployed? What's in the way? How is it being managed? Take us from the top.
Well, there's a couple ways. One is you've got a lot of physical assets that are moving freight around the country. Trucking moves 73% of all stuff in the U.S.
Wow.
And you've got a lot of empty capacity that's trying just to get from one place to another to pick it up. So AI is able to match that supply and demand in a brokerage capacity and really try to, that's the first place
So
we're seeing
first
it.
is logistics?
Logistics, absolutely. That's the first place you're seeing it really roll out. Then you take that from just the existing capacity to then the mobility of the future of, now we have autonomous trucking that's, you know, on the highway. So now you've got people, nobody in the cab, and driving from a starting point onto the highway and then going all the way to a terminal. So we're doing terminal to terminal at this point in the testing phase in the south, where the weather's good, and that's kind of the first phase of where we're seeing it. We're not yet at the point of going all the way through the local roads, you know, and doing drop and hook, but right now it's going from the open road.
Yeah, certainly transformational. But let's talk about the infrastructure. Ken just talked about logistics as an initial starting phase. There's a massive infrastructure needed for that, semiconductors in particular. Can you take us through your thoughts around that?
Sure. I think there are two aspects to it, Chris. One is that even before we start deploying that infrastructure, we first have to create that brain, right? So we first go through what's called the training phase, where they will define the problem that, okay, now you need that physical AI, whether it's a drone, whether it's a truck or something else. You need to be able to teach it about it. So it's almost like training a child. You have to teach it about its surroundings. You know, teaching a child the difference between a dog and cat is easy. Teaching that to a computer, insanely difficult. And then once that brain is taught, then you try to go through a second phase, which is simulation, right? And in many ways, the interesting thing is that the companies that are involved in this are many of the same graphics companies that are also involved in the gaming industry, because they have to take the car through a set of obstacles and make sure that it can react very quickly to somebody coming in front of it.
And you're creating a synthetic environment.
Exactly. So you create that. And then the third phase is, now that you are satisfied with the quality of the brain, you are able to put it out there, now you start doing test trials. So it's when you get to scale, is now you have this backup infrastructure, right, that you can call on. That infrastructure needs to be flexible. You know, so for example, if it is supporting self-driving cars, you have a lot more cars driving during the day than at night. So what do you do with that infrastructure at night? Maybe you use it to train the next brain. So you're absolutely right. I think having that infrastructure and these different phases of how sensing, computing, storage, networking, I think all these are very important components, and semiconductors are involved in each of those steps.
And that's semiconductors. You mentioned graphic cards. You mentioned graphic, what I call is a networking way to learn on itself.
Right.
That's very different than 20, 30 years ago when it was memory for the most part. How has the semiconductor industry changed? And how is it going to change in the next 2 or 3 years?
I think the biggest transformation has been in this move from serial to parallel computing. Right? So serial computing is like you have an army that has just one soldier. It breaks the tasks into small steps and it does that task one after another. That's what the CPUs in the PCs used to do. Now the problem is that data is not stored in such a simple way. So if you take your favorite social networking application, it knows 5,000 things about you. How do you put that in a simple database? You can't. So now you have to train the computer to think in a very parallel way. And that is what a lot of these graphics chips are insanely good at. Thinking about what's called unstructured data, right? And AI is one of the best examples of unstructured data, right? When we go and ask these AI chatbots a question, there isn't like a simple database that they can just look into and give us an answer. They're able to construct answers. So what is different is this move from serial to parallel computing. The second big difference is that doing parallel computing is easy to say, but it is very power intensive. That takes a lot of space, power, transportation, utilities. So now you have to worry about a lot of that infrastructure making. So those are probably the constraints. And that's why a number of the companies that we track, now they have gone from being just a chip company to being systems companies, right? They have to think about every aspect of the stack, how to bring it all together. And the ones that are successful are the ones that I think can think about this problem as an end-to-end systems problem, as opposed to, I just make the chip, throw it at a customer and let them worry about the rest.
And to take that one step further, that's exactly what the trucks are doing, is if you find a construction detour, the first truck that runs it now is telling all the other trucks in that system, hey, you've got to learn this. And in the downtime, they're training each other on new scenarios. So it's constantly learning.
What about the cost line for these companies? Are there ways that the transportation sector is already using this intelligence, if you will, at the cost line to expand margins?
You just think about the excess utilization, 10, 15% of your capacity is just deadhead, empty driving. So if you can refine the routing and to keep the drivers busy, using AI to refine that matching of the supply and the demand, getting just much more efficient. So that's certainly the first phase. But you still have depreciation, you still have gas until we go all electric, you still have all the other costs, and you still have congestion issues on the highway. But if you're autonomous, you can do things at different times of day. So you were talking about at night driving. So if you can do that, you can just get more efficient with use of the asset.
As safety standards improve with autonomous vehicles, is that something that could potentially change and bend the cost curve a little bit better?
Presumably, a computer would be a better driver in proven circumstances than a human because it can react a lot quicker and can anticipate certain things if people are doing what they're supposed to be doing as opposed to not, right? And so in those cases, absolutely, you can start to see insurance costs come down, labor costs come down, but the regulatory environment has to adapt over time, right? So you definitely have this corridor down south that is willing to test it. There are certain states that are holding out. They want to see it get a little bit further, but we're having robo-taxis and autonomous trucks testing in many, many different markets around the country. So it's moving faster than the regulatory environment can adapt.
That's amazing. Let's talk about the final question. Let's talk about risks. Clearly there's risks in the transportation sector as you get more and more physical artificial intelligence infused into the business. And what are the top few that come to mind?
Well, look, I mean, every safety has to trump everything. And there is no room, right? You get one accident and it can set the industry back years in development, right? Or months, quarters, years. So you have to make sure that it is ready for prime time as you roll this out. When you're putting it on, if you're going to have your family of 5 driving next to a truck, an 80,000-pound truck with nobody in that cab, right, you have to make sure that it is buckled up. So that's the only risk that matters to start, right? Yep. Then the risk is, can it be hacked? What's the protection of the asset? And you have to remember, this is a company's freight. That's their lifeline. So if I'm going to give it to somebody who, it's my brand name on it. It's their freight. It's their goods.
That's a great point. Vivek, how about you?
Yeah, I think the same thing in that it has to be evolutionary, right? I mean, technology can do many, many things, right? But as Ken mentioned, how quickly can a specific society adopt it, right? And we see different behavior in Asian versus Western, right, societies, right? There's a lot more deployment and adoption of robotics, right, in the East, right, in Japan, Korea, right? There's a lot more deployment and adoption. Why? Because it's just tougher to find help. There's a lot more older people in certain places. But one thing the automotive industry has done is go through different levels. So cars come in different levels of safety. So level 1 is just kind of your plain vanilla car. Level 5 is your ultimate self-driving, go anywhere. But then you have level 2, level 2 plus, level 3. So every step brings about more safety features, and they are very careful in calling it co-pilots and assisted driving. Right? Like, we have co-pilots in the sky. So I think it's going to be evolutionary, but I think it is inevitable.
This has been fascinating. Ken, Vivek, thanks for joining me today. As AI moves out of the digital world and into the physical one, execution, reliability, and scale begin to matter more than just novelty. This next phase may be harder, but it's also where the real economic impact will be created. Thanks for joining us. We'll see you next time.